Depth first search is for a graph. Graph it has nodes and edges, and here in a graph one node can be connected to any other node, and we traverse all adjacent vertices one by one. So now depth first search follows a particular strategy. So I start from one particular edge, and then I move till I reach the adjacent vertex which is not visited. And then I come back. If there are any other paths that are unexplored from the previous node, I check that. If there is any other path unexplored from the previous node, I again check that, and so on. So graphs may contain cycles and a node may be visited more than once. We use so to avoid processing that, to avoid that, we use a boolean visited array to indicate if that node is already visited or not. So now let us take this example, and let us consider 0 as the start. So initially I mark 0, and then I move to 1. From 1 the path that I see coming out is 2, and from 2 let's say I move back to 3. From 2 I move to 3. So 0, 1, 2, 3 are visited, and then I come back to 2. I check 4 is unvisited, and so I'll mark 4, and then I will check 2 is taking me to another node which is visited, so I will not go back there. Come back to 1. 1 I here in 1 I see that there is no nodes that are unvisited, and only 0 which is taking me to a visited node. So this is the strategy that gets used by depth first search. Initially, for every neighbor that is not visited, I will perform DFS. So this is the basic strategy of DFS. Let us see the program for DFS. So here I am marking neighbors of A, neighbors of B, neighbors of C and D do not have any neighbors. So basically my graph is going to look something like A connected to B, A also connected to D, and then I from B, this is connected to C, and from B I have a connection to D. C and D do not have any neighbors. So this is my graph for this thing. Now let us see how do so let us see the I'm calling DFS and passing the graph. Here I am marking the visited as none. So if visited is none, I am creating a set and adding start to it. So here I am printing the start node. A will get printed. Then A and then a space for neighbor in graph of start. Now graph of A has B and C. So here I will check B. If it is not in visited, yes, it is not in visited. Then it will recursively call DFS for B. So once it called DFS for B, B will be put in visited set. It will check for the neighbor, that will be D. Again, that will be the DFS of D is going to get called. Once it calls DFS of D, D will go to visited set. Are there neighbors? No, there are no neighbors. So it will come back to DFS of B. It will check, is there any other neighbor that is not visited for B? No. It will come back to A. Is there any other neighbor that is not yet visited? Yes, there is C. The loop will run, this loop will execute once again. It will call for C. Is there any neighbor of C? No. Then it will, every neighbor of A, which is the start node, are processed, and so it will give me the result A, B and D, and then C.